Today we'll be talking about differentiation of implicit function. But before we proceed on implicit differentiation, we must define what is the difference between explicit and implicit functions. We have here an equation where y is equal to 3x plus 2. This is called an explicit function, since the dependent variable here, which is y, is defined clearly in terms with the independent variable. So y here is defined as an explicit function. Also, we have another equation that is y squared is equal to 3x plus 2. This is called an explicit function, since the dependent variable is not stated clearly. Since y here has two values, for example, that if we take square root to both sides, we have square root of 3x plus 2. This is positive, negative. So y has two roots, whether this positive square root of 3x minus 2 plus 2 or y is equal to negative 3x minus 2. If this will be equal to f1 of x and this will be f2 of x, and all of these functions is a domain of x. So clearly y is equal to f of x is defined as an implicit function. Now moving on to our topic, the implicit differentiation. So we have here y squared is equal to 3x plus 2. Now there must be a rule on answering this equation. So our rule here, we must differentiate each term of our function, and we must obtain the derivative of the function. So in this case, if we take the differentiation in terms of x, we have 2y. Since our dependent variable here is y, so the derivative of the dependent variable is simply 2y dy dx. Or we can rewrite this dy dx as y prime. And it's equal, the derivative of 3x is 3 and the derivative of a constant is 0. So we must obtain our differentiation of this function in such a way, and our left-hand member is our derivative. So dividing both sides with 2y, we'll get y prime is equal to 3 over 2y. Now, as I said earlier, that y squared has two roots in such a way that f sub 1 of x is equal to 3x plus 2 and f sub 2 the function of x is equal to negative 3x plus 2. Now, if we take the differentiation of this function, we must sure that our resulting function must be equal to this method. So in this case, we have f prime of x. Now the derivative of a square root of 3x plus 2 is simply 1/2 3x plus 2. 1/2 minus 1 is negative 1/2, and the derivative of our inside function according to the chain rule is 3. So we have f prime of x is equal to 3 halves over 3x plus 2 raised to 1/2. Now notice that our 3x plus 2 raised to 1/2 is simply our y. So we have f prime of x is equal to 3 over 2y. Hence we have the same answer. Now if we take also the derivative of our second root, we have f prime of 2x is equal to negative derivative of the square root of 3x plus 2 is 1/2. 1/2 minus 1 is negative 1/2, so we have 3x plus 2 raised to negative 1 half, and the derivative of our inside function we have 3. So this is equal to negative 3 over 2 square root of 3x plus 2. We can also rewrite this as 3 over 2 negative 3x plus 2. This is equal to the previous function. So notice that this one here is our y, since y is equal to negative 3x plus 2. This is a root of y in the negative world. So we have f prime of 2x is equal to 3 over 2y. Hence, we also arrive at the same result. Okay, we have here another example. We must find the first differentiation of this function. So we take the differentiation of each term in terms of x. So differentiating this in terms of x by dx, we have the derivative of x cubed is simply 3x raised to 2 plus 3y raised to 2 y prime minus this one here. We can solve this according to the product rule of differentiation. So we have negative 3. We can solve xy since both of these is a function of x. We can solve this according to product rule of differentiation. We have here x dx of y plus dx of x of y is equal to 0. So 3x squared plus 3y squared y prime minus 3x, the derivative of y is y prime, so 3 times x y prime is x y prime. And the derivative of x is 1 and y, then 3 negative 3 multiplied by y is negative 3y is equal to 0. Notice that each term has a value of 3. We can further simplify this as we divide both sides with 1/3. So we have x squared plus y squared y prime minus xy prime minus y is equal to 0. Now group all like terms. We have here y prime. So y squared minus x multiplied by y prime. So this is equal to this one. And we transfer x squared minus y to the right hand member of our function. We have y minus x squared. Dividing both sides with y squared minus x. Hence, our y prime is equal to y minus x squared over y squared minus x, where y squared is not equal to 0. Now we have here another example that we are asked to solve the first differentiation and the second differentiation of the function x squared plus y squared is equal to a squared. Now, find y prime. Differentiating the function, we have 2x plus 2y y prime is equal to 0. Why 0? Since a squared is a constant and the derivative of a constant is 0. Obtaining y prime, we have y prime is equal to negative x over y. Since both terms have 2, you can simplify this by multiplying both sides with 1/2 and transferring x to the right hand member. We have negative x and dividing both sides with 1 over y. So we have over y. We have here y. So y prime is equal to negative x y. Now we are asked to take the second derivative. So from this, So from this, we take our second derivative with respect to x. So we have derivative of y prime is y double prime is equal to, this one is, you can solve this according to the division rule, where low d high minus high d low over low squared. Applying this formula, we have here negative, our low here is y, is negative y, the derivative with respect to x of x, minus our high here is negative x, multiplied by dx y over y squared. So y double prime is equal to the derivative of x is 1, so this will become negative y, and this one will be positive, so positive x y prime over y squared. So our second derivative of y is equal to negative y plus xy prime over y squared. From our previous formula, y prime is equal to negative x over y. Substituting y prime, we have negative y minus x squared over y. Since x multiplied by x is x squared over y squared. Simplifying, we have negative y squared, since we have a term here over y, so we multiply this y here, minus x squared over y, and the reciprocal of y squared simply 1 over y squared. We have, taking negative outside, we have negative x squared plus y squared over y cubed. Now, from our original equation, x squared plus y squared is simply equal to a squared. So x squared plus y squared is equal to a squared. So our second derivative is equal to negative a squared over y cubed. So we are asked here to find the first derivative of our function. Now, taking the derivative of each term with respect to x, we have, according to product rule, this is equal to the derivative of x fourth is 4x cubed y squared plus x4 multiplied by the derivative of y squared is 2y y prime minus 7, our constant. Then the product rule, derivative of x is 1, so we have y cubed. Derivative of y cubed is plus x 3y squared y prime equal to negative 8y prime. So simplifying, multiplying the constants to the each term, we have 12x cubed y squared plus 6x fourth y prime, because of 3 times 2. So this one will become negative 7y cubed. 7 times 3 is 21, so negative 21 y squared y prime is equal to negative 8 y prime. Now grouping all terms with y, this one, this one, this one. So we will have 6x4y minus 21y squared, negative 8y prime will become positive if you transpose to the left side. So this will become positive 8 multiplied by y prime, and the remaining term transposing into the right side, this will become 7y cubed minus 12x cubed y squared. And dividing this to both sides of our function, we'll have y prime is equal to 7y cubed minus 12x cubed y squared over 6x fourth y minus 21y squared is 8. Find an equation of the tangent line to the curve of x cubed plus y squared is equal to y at the point 1, 2. So if we take the differentiating implicitly the function with respect to x, we have 3x squared plus 3y squared y prime is equal to 0. By multiplying both sides with 1/3, we have y prime is equal to negative x squared over y squared. Because of this, the 3 will cancel out, so transposing x squared to the right side, we have negative x squared. Dividing both sides with y squared, we have y squared. From the definition of the derivative, y prime is dy dx, and this is equal to the slope of the line. Then, at the point 1, 2, we have m is equal to negative 1 over 2 raised to 2 is 4, so 1. From our equation of the line, which is y minus y sub 1 is equal to m x minus x sub 1, where our x sub 1 here is 1 and y sub 1 here is 2, and our m is negative 1/4, so y minus 2 is equal to negative 1/4 x minus 1. Simplifying, we'll get y is equal to negative 1/4 x plus 1/4 plus 2. This will become y is equal to negative 1/4 x. This will become 1/4 plus 8 over 4. 8 plus 1 is 9, so 9/4. This will become plus 9. Hence, this will be our equation that is tangent to the line of the curve x cubed plus y cubed is equal to y. Okay, that will be all. See you in our next video, and God bless on your exam.